Now that we've seen some of the additional techniques you can use to transition to a state, let's update the links in our navigation bar to use them instead of URLs. We'll now be transitioning to a state based on the state name. The states we have so far are named Home, Schools, Classrooms, and Activities. I'll now open index.html so we can update the links. Instead of using the href attribute on the anchor tags, we're now going to use UISREF and pass it the state name. The first one I'll update is the link to the home page. I'll just delete the href and add the UISREF attribute set to Home. I'll do the same thing down below with the other links in the navigation bar. I'll use UISREF and set them equal to Schools, Classrooms, and Activities. Just to make sure I didn't break anything, I'll go refresh the app and click each of the links. Everything still works. However, the links are now not tied to the URL defined on the state. Just to prove that, I'll go back to the app.js file and comment out the URL property on each of the states. I'll refresh the app again and we'll see that all of the links still work. However, because there is now no URL associated with the states, the browser's address bar doesn't change as we move from one to another. That's an interesting trick, but I think you'll be better off defining URLs for your states. It will make it easier to support deep linking and passing of parameters, which we'll look at soon. I'll go back to the code and uncomment the URL properties on the states. Let's now take a look at some of the features of the state service. I'm going to add a refresh button to the home page, much like the one I added in the module on NGRoute. I'll start in the home controller. The first thing I need to do is inject the state service. I'm also going to inject Angular's log service just so we can output some debug information to the browser console. I'm going to define a new function on the controller's view model named refresh. The first thing it will do is log the current property of the state service just so we can see how to access the current state and the structure of the object contained in that property. Next, I'm going to call the reload function on the state service so we can see how it works and how it differs from clicking the browser's reload button. To wire up the new function, I'll go over to the view for the home state, which is in home.html. I'm just going to add a new button that uses ngClick to call the function on the controller. I'll add a couple of CSS classes just so it matches the rest of the app and put the word refresh on the button. I'll go back to the browser and open the developer tools in Chrome so we can see the output sent to the console. When I reload the app, we see the new button appear. I'll go to the Network tab just so you can see all of the network traffic that occurs as part of clicking the browser's refresh button. So you can see it live, I'll clear it and click reload one more time. You can see that it downloads everything required for the application and then makes the AJAX request to get the data needed by the home state. To see how calling the refresh function on the state service is different, I'll clear the Network tab again and click the new button. You can see that it only did the work necessary to refresh the current state. In the case of the home state, that meant making 3 calls to the server to get schools, classrooms, and activities. That's a handy piece of functionality when you need to refresh what the user sees, but you don't want to refresh the entire application. I'll now open the console tab so we can see the result of logging the current property of the state service. As you can see, it logged an object that looks nearly identical to the state configuration object we added in app.js. This gives you a handy way to inspect states programmatically if you need to. Let's now add some code to handle the events defined on the state service. To do that, I'm going to add a run function to our main application module defined in app.js. Angular modules declare a function named run that gives you a convenient place to do some initialization of your module. I'm going to use it here to define handlers for the events on the state service. I'm going to handle events on Angular's root scope, so I need to inject it into the function. I'm also going to inject the log service so we can output some information to the browser's console. I'll paste in a code snippet to handle the state change success event. I'll collapse the project window just to make a little more room. You handle events on the root scope by calling the $on function and passing it the name of the event and a function that should execute when the event occurs. The handler function for the state change success event takes 5 parameters: the event object itself, the state you've successfully transitioned to, the parameters passed to the state you came from, and the parameters passed to that state. Rather than do something interesting with all of that information, I'm just going to log a message that we've successfully changed states and then dump all of the parameters to the console so we can have a look at them. I'll paste in some similar code for the StateNotFound event. Its handler takes 4 parameters, but I'm just going to use one of them to log the name of the state that was not found. The last event we'll handle here is the state change error event. It takes all of the same parameters as the state change success event handler with one additional one on the end that is the error that occurred. We can already test the code that handles the state change success event, but I need to force some problems if we're to see the results of the not found and error events. To do that, I'll scroll back up to the classroom state. I'm going to add a resolve property to it that will throw an exception. We saw ngRoute's resolve property in the last module, and the one in UIRouter is very similar. We'll take a closer look at it in a bit, but it is basically a way to execute some code before the state transition takes place. Since this code will throw an exception, it should fire the state changed error event. To cause the StateNotFound event to fire, I'll open the index.html file and change the UISRef that links to the state named activities to link to activities ABC instead. I'll now refresh the app. When I click the schools link, we can see the results of handling the state change success event. We can see in the console the message I added as well as each of the parameters to the event handler that I simply output to the console. You could obviously inspect any of those in your code and take any action you needed based on what you find. I'll clear the console and click the Classrooms link, which I configured to throw an exception and generate a state change error event. The output is similar to the state change success event, but you have the additional error value you can inspect. I'll clear the console again and click the Activities link, which I configured to go to a non-existent state. As you might have guessed, we get some information in the console about the name of the state that it couldn't find. I think it's a good idea to always handle the state change error and StateNotFound events, since they obviously only occur when something bad has happened in your app. It's always a good idea to detect bad things and at the very least give your user a friendly message informing them that something went wrong. Handling the state change success event is only something you need to do if you have a particular need to inspect the details of the state transition. I'll now go back to the code and remove the errors I added. I'll set the activities link back to the correct state name and remove the resolve property from the classroom state. Lastly, since I don't want the browser console filling up with the details of every successful state transition, I'm going to comment out the code that handles that event. Let's now go see how to work with state parameters.